Hello everybody, this is Steve again. This is a follow-up video to my Supercharger in a box video that I did a few months ago. Basically where I have a electric motor powered Supercharger driving my Honda S2000. And the video before it was on the bench. And now it's in the car. And it's working really, really well. In fact, I put this guy in and I guess it was good that I did all that bench testing because it pretty much worked right off the bat. Almost no issues at all with it. I'm having problems with the fuel system. I'm not getting enough fuel to the engine, so I haven't cranked the boost up very much. Only about 3 or 4 psi. And for right now, I'm running 100 octane Sunoco fuel until I get the fuel system correct to give me some margin. I guess not. But let me show you kind of what it looks like. If you guys remember, this thing is actually in a box. So this is what it looks like in the box. This is a stock S2000 air box. It's been modified quite a bit. And it's in an air box because I don't like the electronics, the motor and stuff in the engine compartment. I want to keep it cool. And this right here is pretty much where the stock cold air input is, the Honda. Cold air comes in here, and there's 2 fans that pull air through this box to keep it clean, keep it cold. So this is a kind of reminder. There's the Supercharger. This is power coming into it, 3 cables. This is the electronic speed controller. This is the super controller, which is a custom thing based on Arduino that is kind of the brains behind everything. This is the electric motor. It's putting out about 14 horsepower. That's a free RC Hobby Outrunner motor. I've also got an intercooler right there, which is a stock off-the-shelf intercooler. It's designed for a Supercharger a lot bigger than this one, so it works really well. It has no pressure drop, and it's really doing a good job. This is the oil reservoir for the Rotrex, which it needs. And what else can I show you here? In front, I guess if I can show you, there is, if you can see it, there's the heat exchanger. I bent some sheet metal right here to kind of make a crude air box around that because the fans were blowing hot air right on the air filter, so I fixed that. And the bottom line is if I can figure the fuel system out, it really, really works well. It's amazing how strong 4 pounds of boost feels when you don't have the load, the motor, or the Supercharger on the crankshaft, and you have a really good intercooler. And it's a flat boost curve from 3,500 to 9,000. It just transforms the car. I may just leave it at 4 psi and not even go to 6, which it should be able to go to. But I can electronically turn the boost down with that Arduino, and that's where I am now until I get the fuel working. Here's the battery in the trunk. Pretty straightforward. My golf clubs will still fit across there. These are the connections here for the 3 cables. Pretty straightforward. The 3 cables run under the car. My original plan for the fuel system was to use a rising rate fuel regulator. This is a Vortec one. And basically it raises the fuel pressure to the fuel injectors with boost. And it raises it at a faster rate the boost goes up. That's a 6-to-1. So at 6 pounds of boost, it's supposed to put 36 psi more fuel pressure, and you'll get more more fuel. Everybody says that they don't work that great. And after putting 2 of them in here, I agree with the critics. It doesn't work that great. So I thought I'd try charge pipe injection, where you take a fuel injector, and this is a Bosch EV14 that I bought. It's about the right size. It's got multiple holes, so I thought it may have a shot. And if you can squirt that into the charge pipe and control it, PW pulse width modulated, here's a injector holder that you can get to weld it in. Put it there, maybe over here. Then you can add some additional fuel. The fuel's got to then go around this bend into the intake manifold. And I didn't know quite what to expect, but it didn't work that great. And here, I'll show you a picture. I don't have a video, but I got a picture. So what I did was I took that Bosch EV14 and I sprayed it into the airstream from my blower, sidewalk blower, And I was just surprised at how little vaporization there was. It pretty much, it's almost like a pressure washer just shooting a stream of water. And you can see it spreads out a little bit with the airflow. And this is quite a bit of airflow. I measured it to be airflow that's in the general range what the engine's going to be doing. And it just didn't vaporize at all. And if you put a pipe right there, it just hits the pipe and turns to liquid. I thought, well, maybe I bought the wrong kind of injector. So this is a device from a company called Fuel It, and this is a charge pipe injector. And they advertise this as you just screw it into your charge pipe, hook it up and control it, and it will work. So it turns out this fuel injector, believe it or not, it's also a Bosch EV14 that they scratched the part number out, so you can't say exactly what it is. And I'd say it works slightly better than the one I had before, but I still didn't like it. So here, I'll show you some video how this thing worked. I just don't think all that liquid blasting around is going to distribute among the four cylinders very well at all. So at this point, I'm pretty much giving up on charge pipe injection. So the original reason I'm having fueling problems is because in 2003, the S2000, the engine control unit could not be reprogrammed. You can't chip it, you can't reprogram it. You have to change the whole thing out. And I don't want to do that. People are telling me use a Haltech, use a Honda. In this car, the electric supercharger doesn't run except at wide open throttle. And I don't want to change anything in the stock car how it runs. And when you swap out the ECU, not only do you have to tune it for wide open throttle, you got to tune it for everything else too. Everything else really works perfect. I just want some more fuel and pull a couple of degrees of timing under boost. I don't want to go through all that. So the rising rate fuel regulator didn't work. The charge pipe injection doesn't work. The next thing to do is look at a thing called a Piggyback ECU. Well, you keep the stock ECU, it intercepts sensors and injectors and it changes them. And I don't really like those things either. The ones I've seen, it's a lot of wiring involved. They don't make them anymore for this car, a wiring kit. It's a lot of wiring involved. And I'm not totally bought into the basic idea of them. So I'm going to do my own Piggyback ECU, or give it a shot. I'm a retired electrical engineer, so I can know a little bit about circuits. So what I found is that I think we could stretch the stock pulse and don't actually replace it. So there's a switch in the ECU, it's a FET, and it shorts out, it grounds that injector and turns it on. And then that switch turns off, the injector turns off. I'm going to add another switch in there, so when that switch turns off, I'm going to turn another one on and turn it right back on again. So you get the stock pulse plus a pulse I provide, and it's going to switch between those two pulses so fast that the injector won't even see the transition. That injector takes a few hundred microseconds to respond. This is going to switch in about 20 microseconds. So it's going to appear as one pulse. And the cool thing about this is there's no rewiring. All we do is just tap into the 4 injector wires. Don't cut them, because we're going to keep the stock pulse and we're going to add a pulse to it. And I don't know, maybe that part's, maybe a Piggyback ECU like this exists someplace. I couldn't find it. But I'm an engineer. I can do my own. So let me show you kind of what it looks like. I did a breadboard for it, and it actually works pretty good. Here is the breadboard for the injector pulse width extender. There's an Arduino here. There's the FET that is going to stretch the pulse. And sorry about the dirt in the car. And this stuff tacks into there's the ECU. So here's a wire that just tacks into with a connector, a tie-in connector to grab the injector wire. And I'll show you how it works here in a second. This is a switch right here. If while the car is idling, I push that switch. This guy is programmed to stretch the pulse width 1 millisecond. And I'll show you how that works here in a minute. So this is the injector pulse to one cylinder while the engine is idling. When that yellow waveform is low, that is the command to turn the injector on. You can see it's about 2 3/4 of those divisions wide, which is about 2.75 milliseconds wide. And then when I push the switch, it increases by a millisecond to 3.75 milliseconds wide, which gives you more fuel. Now you see that little spike at the end of the pulse. That is the injector turning off. While that thing is way up there, the injector is in the process of turning off. That's the inductive kick from the injector. And then when you see the added pulse, you see a very, very narrow spike there. That's the thing turning off, and then I turn it on very, very quickly. And that little spike there is too short for the injector to see. So we have a pulse that goes from 2.75 to 3.75 milliseconds. So the next step with this saga is I'm going to build the complete Piggyback ECU. I've already got a printed wiring board laid out, and it's off being manufactured, and I got the parts. It's really very simple. It's just that little breadboard thing I showed you, but it's got 4 channels, one for each channel, with a single Arduino controlling it. And then there's quite a bit of software. We got to put fuel tables in there. There's all kind of checks and balances to make sure we only add that pulse when it's appropriate and whatever. But the good news is I've gotten to where, instead of hacking out my own Arduino code, which I'm not very good at, I'm not a coder, my code looks terrible. I've learned to have ChatGPT write my code for me. Pretty much just specify exactly what you want. In less than a minute, it spits out and it works. And fuel tables, everything we need, I'll have ChatGPT do that. So hopefully in 2 or 3 weeks here, my little Piggyback ECU will be giving a full-blown test, and cross your fingers it works. But I'll fill you in when we get some more data, and hopefully we'll have this thing going here real soon.